here. Let's take some basic correlation examples. The classic one that everybody learns in psychology class about correlation is SATs and GPAs, right? You all know about this SAT test. All right, so you have a graph. Correlation studies typically always have a graph, and you're plotting two things and seeing how they look on a graph. That's it. So SAT score, you know, this is the test that you take like a senior year in high school, right? And the reason they give it is because the tendency is people who do well on an SAT class, the SAT score, one morning in the spring or fall or whatever, the spring, one morning you take a test at 8:30 in the morning and you get a score. And that score, people who tend to do better on that test, it turns out a year later when they're in college and they're freshmen, they tend to have higher GPAs in their freshman year. And people who don't do so well on that test tend to fail out of college or not have such good college GPAs. So this admissions committee in a college knows that if they really want to bank on getting a student in there that they're going to get the tuition from for 4 years solid, it's going to complete the program and go on to bring fame to the college and then donate to the alumni associations that can build a new gymnasium. If they really want this to happen, they know that their best bet is to choose somebody who had a high SAT score. Because people who have high SAT scores tend to then, look at this, high SAT would be here, high GPA would be over here, and here they are. This person had a perfect GPA, a perfect SAT score, and they went on a year later to get a perfect GPA. Now, did taking that test at 8:30 in the morning a year before cause that high GPA? No, of course not. That would be silly. And how about this person? They did terribly on the SAT, and their GPA was very low, and there they fall. This person, person C, they did about average, and they got about a C average in there. You see how the plot starts to go something like this? And each one of these dots is a subject. And we're not saying that SATs cause GPAs. We're simply saying is that there's a trend. There's a trend that we see the data falling in. And this trend states what? As SATs go up, GPAs go up a year later. It's a positive correlation. Doesn't mean it's good. Positive is in the mathematical sense, meaning both go up. It's a positive correlation. Now, on the other end of the spectrum of correlation, we can have something that looks like this. We have two variables, not cause and effect here, we're just looking at relationships. And we find that as one goes up, the other goes down. Who can think of an example of this one? What's one thing that if you do more of it, the other thing goes down? Ooh, I know one. Possibly. Yes?
If you exercise...
I was thinking the same thing, right? Now, we know that this isn't completely the case because there are genetic factors, there are dietary factors, there's lifestyle factors. But if we look at the majority of people, if we put them on a regimented exercise program, say an hour, 4 times a week, 4 hours a week of exercise, inevitably, if other things are taken into consideration, such as amount of calories intake and all this other stuff, basically what you're going to have is this. As exercise increases, so here's 0 hours exercise, and here's, say, 5 hours exercise a week. Inevitably, if you're moving, calories are going to burn. It's very simple mathematics here, or science. So as exercise increases, we might have, it's actually an interesting thing is it's not always body weight that changes. Because as muscle builds, muscle is heavier than fat. So you can actually get into shape and weigh more. So what really is going to change here is the body fat content to muscle. But that's interesting. You can actually gain weight from doing exercise. So let's look at body fat. Call it BFI, body fat index. So this is more. Exercise goes up. This person's exercising 5 hours a week, and we notice that their body fat is going down. This person exercises this much a week, and their body fat's, where is it going? How does this work? Yeah, this person exercises a lot, and their body fat is little. I put the dot in the wrong place. This on a person exercises very little, their body fat is up. You see you start to fall in this kind of distribution. And you see that this trend goes in a negative. It's a negative correlation. As one goes up, the other goes down. We call that a negative correlation. Now, I know this is going to be a little confusing because we can very easily say that exercises causes body fat reduction, right? But in correlation studies, we're not looking at, we're making no causal claims. We're just saying it just so happens that there's a relationship here. Now, of course, you can get someone like this. This person exercises 5 hours a week, they even more, and they're actually, their body fat's not going down. What's going on here? They're an outlier. This person doesn't exercise at all, but that their body fat is really low. So you see, these people are called outliers. These are people who operate differently than most. So what could some of the factors be? Well, the person who is exercising all the time, but the body fat doesn't change. What could some of those reasons be? Genetics. You might have a certain genetic makeup. This is your body type. I mean, not everybody can get. Very fascinating example is, in our society, we have this. I walk around. It's less so now today than it was 10 years ago or 8 years ago when I was working on college campuses as a therapist. 10 years ago, all the girls were like super, super svelte. I mean, to the point that it was like over the top. And I knew from studying, I worked very closely with someone who did therapy on eating disorders, that only 11% of the population naturally have that really kind of skinny, body type. 11% of women and naturally have that body type. That's their body type. So that means out of 100 girls that I see walking around with that very svelte shape, 11 of them have that naturally. They don't have to alter their diet. They don't have to do excessive exercising. The rest of them are going through all kind of stuff to get that way. Excessive exercise, purging and all that kind of stuff, making themselves throw up, laxatives, excessive stuff. So this is interesting to think there are other factors involved here. And there's ways around it, but there's other factors involved here. Any questions or thoughts about this? Correlation?
It's not causation.
It's not causation. That's it. Now let's look at one right in the middle. Right in the middle we have, here we had a perfect positive correlation. All of them are going up and down. Here we had perfect negative correlation as one went up there, the other went down. In the middle we have zero, no correlation. There's no relationship between two things. Can someone in here think of something that has no relationship? This has no relationship to the other variable. What do you think? Two are completely unrelated.
Your violent media, violent behavior.
Violent behavior and violent media actually show that as violent media is consumed, violent behavior goes up. So that would be a positive.
You said that was a positive.
That's a positive correlation. I'm looking for no correlation whatsoever. Things are completely not related.
Okay, coffee and math.
Ha! Here we go. Hold on here. Eating and getting smarter. So IQ and caloric intake. There's no relationship here. It doesn't matter how heavy or how svelte somebody is, has nothing to do with their IQ or their test scores.
So you said eating and getting smarter?
Yeah.
Oh.
How about this one? Shoe size and IQ. Height and IQ. Taller people aren't smarter, shorter people aren't smarter. Height and IQ might be a good example. So here is height. Here is IQ score. And what we get is people falling all over the place. There's no relationship whatsoever. Does that make sense?
Mm-hmm.
So that's called a zero correlation. And of course, we can represent this graphically, as you all learned it in intro and as I just showed you, but you can also represent it as coefficients. In other words, as numbers. Numbers are coefficients. So here are the numbers. In the middle, we have zero correlation, no correlation. On the positive end, we have what's called, it's a number line, perfect positive 1.0 positive. And down here, we have a perfect 1.0 negative correlation. Does that make sense? So you might see in a research study So this is the part, now again, where we go from intro, where it's more basic, to this 200 level class, we're getting a little more into the details here. So if you